The power rule for differentiation says that if we have a function f of x equals x to the r, then the derivative of that function is found by bringing the exponent down in front and then subtracting 1 from the original exponent to get a new power. Let's try it here with the function x squared. We want to find the derivative. So we should bring the 2 down in front and then subtract 1 from the 2 in the exponent to get a new power of x. That'll be 2x to the 1, which simplifies to just 2x. Let's try it for x cubed. Bring the 3 down in front. Subtract 1 from the 3. 3x squared is the derivative. X to the 5th's derivative would be 5x to the 5 minus 1, which is 5x to the 4th. Now let's try it on just x itself. It's worth noting that x can be rewritten as x to the 1. Now we can use the power rule on it. Bring the 1 down in front and then subtract 1 from the original exponent. That'll give us 1x to the 0, which would be 1. What if we were to do it to x to the 0? We'll bring the 0 down in front, subtract 1 from the exponent, but since there's a 0 in front, it's not going to matter what the exponent is, the result will be 0. And it's worth noting that x to the 0 could be rewritten as f of x equals 1. And that shows that it's in agreement with our previous rule that the derivative of a constant is 0. What about this? X to the negative 1. What will its derivative be? Negative 1x to the negative 1 minus 1. That's going to be negative 1 over x squared. I'd rather use a positive exponent for that one. And how about this one? It's worth noting that 1 over x squared could be rewritten as x to a negative 2 power. Now we can bring that negative 2 in front and subtract 1 from it. That would give us negative 2x to the negative 3, or negative 2 over x to the 3. That's the power rule. Now let's try the rule for derivative of a constant times a function. This rule says if you're trying to find the derivative of k times f, where f is a function of x, but k is just some number, then what we can do is we can actually pull the k out front and then just find the derivative of f. I'll try it in this example. I want to find the derivative of 3x. Well, I can pull the 3 out front and then just find the derivative of x. Numbers can come out front, but functions of x have to stay behind. So that's going to be 3 times 1, which is 3. What about this? The derivative of 4x squared. Pull the 4 out and find the derivative of x squared. We saw above that it was 2x. So our final answer looks like 8x. If we want the derivative of 8 over x to the 5th, we can pull the 8 out front and find the derivative of x to the negative 5. It's going to be negative 40 x to the negative 6.